Alright, hello everyone. Yes, my microphone is working. Okay, so welcome to this video, which I hope will help you with questions 5 and 6 on homework 2. So there's multiple ways to solve this question. I think Quest does it differently than I do. And if you have your own way that makes sense to you, go for it. But this is the way that I did it, and it makes sense to me. So that's why I'm going to show y'all. Okay, so what's happening is that there's a bird and there's a person. So the bird and the person are going to start at some distance away from the finish line. For me, it's 4.9 kilometers. For y'all, it's probably going to be different. So then the bird and the person go. So the bird goes and the person goes. I'll do the person like blue. And then once the bird reaches the finish line, because the bird is going to go faster than the person, the bird turns around. And then at some point, like right here, they intersect. And then our goal is to find the distance that the bird travels, like to the finish line and then back to the person. So we need to find like this distance and that distance. So how far did the bird go before reaching the person? Okay. So I like to use equations to model what's going on in real life. So I'm going to write an equation for the bird, and then I'm going to write an equation for the person. We're going to find where they intersect, and using that time, we can figure out how far the bird traveled. Okay, so let's start with the bird. It tells us that the bird travels at a steady velocity, right? They both travel with a steady velocity, so that means the velocity is not changing. So if the velocity is not changing, like constant velocity, that means it's a straight line on a position versus time graph. Okay? So if I have a straight line, I'm going to use y equals mx plus b. And that's my general equation for the straight line. But instead of using y, I'm going to use d for distance. And instead of using x, I'm going to use t for time. So then m is my slope. And since I'm modeling position versus time, my slope is my velocity. And t is time, and b is like my y-intercept. It's like some number to adjust so that my model does what I want it to do. Okay, so let's start by defining like my directions and my coordinates. To make it easier for me, I like going that way is positive, and then going that way is negative. So to the right is positive, to the left is negative. And I'm going to say that this point is our reference 0. So at that point, I'm going to call that 0. Okay. So let's start with the bird. So d equals the speed of the bird. All right, so the speed of the bird is 13.2 kilometers per hour. And we're going to the right, so it's still going to be positive. So 13.2 plus some number that we don't know. Okay, so our model says that we've traveled 0 distance, or I forgot the t. T plus some number we don't know. Okay. So our model says that at t equals 0, our distance equals 0. So if I plug in 13.20, that should equal to 0, right? So that means like b is 0 for the first part. Cool. So it's just 13.2 times t. Okay, and then this is when the bird goes towards the finish line. So this is all going to be towards the finish line. Okay. So the bird travels 13.2 kilometers per hour and is going towards the finish line. So this only applies for when t is from 0 to some number when it reaches the finish line. Because then after it reaches the finish line, so it'll be like negative 13.2 t, because it's going the other way, it's going to the left, so I make my velocity negative. So we gotta find out like how long it takes to go to the finish line. So we know it travels 4.9 kilometers, right? This distance is 4.9 kilometers. At the speed of 13.2 kilometers per hour. So we gotta find time, so speed equals distance divided by time. 13.2 equals 4.9 divided by t. So solve for t. you do algebra, that's going to be 4.9 divided by 13.2. So t equals 0.3712, and it just keeps going. Okay, so that's the time it takes reach finish line. So now we're going to find our equation for the bird going the other way. So now it reaches the finish line and it goes back towards the person. So that's going to be this. I'll do it in different color. I'll do it in green. All right, so we need to find some equation to model going back. Okay. So then d equals, now our velocity is negative 13.2 t plus some number that we don't know. And this is valid from t is greater than 0.3712, right? Okay, and to find that some number we don't know, we use what we do know. So we know that it takes 0.3712 hours for the bird to reach the finish line. So then 4.9 equals negative 13.2 times 0.3712 plus some number, I'm gonna call it b. All right, because we know the bird takes 0.3712 hours, and at time equals 0.3712, it is at the finish line, so it has traveled 4.9 meters. So solve for the number for our y-intercept. So negative 13.2 times that time. So negative 4.9 equals 4.9 plus b. So add 4.9 to both sides, so 4.9 plus 4.9 is 9.8. Was b. Cool. So this is our model going away from the finish line. Cool. So there's our two equations for the bird. Now we're going to find our equation for the person. Person's pretty nice because the person only goes in one direction, so we don't need to mess up any of the equations. So we just do our person, the distance our person travels is the person's speed. So 3.3 kilometers per hour, and he goes to the right, so it's still going to be positive times whatever time. Cool. So we got our models for our bird going towards the finish line. We have our model for our bird going away from the finish line. Now we got our model for the person. So now we're going to find out where they intersect. Okay. So they intersect at the same distance, because at the same time, it's like right there, the person travels that far, and the bird is at that position, right? They're at the same position. Because they intersect, you have to be at the same point at the same time. So I'm going to set this equation, the blue one, equal to the green one, because they're at the same distance at the same time. So then 3.3, maybe I'll do this, and I'm feeling purple. So 3.3 t equals negative 13.2 t plus 9.8. So I solve for t, and that's the time that they intersect. So plus 13.2 t plus 13.2 t. 3.3 plus 13.2, 16.5 t equals 9.8. So 9.8 divided by 16.5. So t equals 0.5939, it just keeps going. Hours. So after 0.5939 hours, that is when the bird and the person intersect. Cool. So all that work, but our end goal is to find that the distance that the bird travels, right? Cumulative distance the bird travels. Okay. So the bird travels. So the bird has speed of 13.2 kilometers per hour. And it does that for 0.5939 hours. So speed equals distance divided by time. So to solve for distance, you just multiply your speed and time. So 13.2 equals distance times 0.5939. So distance is 13.2 times, not that one, 0.5939. So 13.2 times that time is our distance, and that is 7.84 kilometers. Cool. So that is our distance that the bird travels. Awesome. So just use my models for the person and the bird. Right, I modeled the distance that they travel against time. Find out where they intersect. And then I use that time and the bird's constant speed to find the distance the bird travels. So that is when the bird goes forward and back and meets the runner one time. Number 6 tells us that the bird and the runner, like, they keep doing that. So I'm going to draw my picture in. So there's my runner. There's my bird. So the runner goes, and then maybe I'll do the runner in blue to be consistent. Did I do in blue? Yeah. So the runner goes towards the finish line, and then the bird also goes towards the finish line. Right? But the bird keeps going back and forth. So it'll go there, it'll go back, it'll go back there, and it'll go back again, it'll go back there, and it'll go back again, all the way until the runner reaches the finish line. So what we want for number 6 is the total distance that the bird travels, like, until the runner reaches the finish line. So you can't do what we just did again. That's totally fine, but you'll find out, like, it takes forever. And I know, because that's what I tried to do. So what I did is, like, I just graphed in Desmos and did it a bunch of times, and that took way too long. So the way I'm going to show y'all how to do it is going to be a lot simpler. So if we read the problem again, it tells us that the bird travels 4 times as fast as the runner. So if you travel 4 times more than someone in the same amount of time, or you travel 4 times faster, you're going to travel 4 times more distance. So bird travels 4 times faster than a runner. So because it travels 4 times faster, it travels like 4 times the distance. 4 times the distance. All right, this only works if they, like, move the same amount of time, which they do. So if you travel 4 times faster than someone, you're going to travel 4 times the distance of someone. So the runner traveled 4.9 kilometers. So that means the bird travels 4 times 4.9 kilometers. 4 times 4.9 kilometers. That is going to be 19.6 kilometers. Sweet. Okay. So that's it for the bird question. I know this is, like, really hard, but again, the homework's going to be at a 10 level, and the tests are going to be like an 8 level. So I don't think you'll see this on the test, because first of all, you only have 45 minutes for your test, and this problem took me about, like, 10 minutes already, so that's, like, way too long. But if you can do this problem, it's good for you, because, like, you practice, like, modeling using equations to describe something's motion. Yeah, if you have any questions over this, I'll always be glad to help you. If you have questions on literally anything, I'll always be available for you, and I want you to be successful, and I hope this was successful. I have to go to my fantasy football drafts. I have the 3rd pick, so hopefully I'm getting Christian McCaffrey or, like, Jamar Chase. Wish me luck, and I hope y'all have a good night.